Hey everyone, thanks for joining today's Lunch and Learn Atomic Assessments for Math in your LMS. I'm Lauren Romano, and with me from Atomic Jolt, I have Joel Duffin. He's our CEO and founder. And I have Heidi Vincent. She is our curriculum developer and project manager. Today, we're going to show you our Atomic Assessments tool and how it seamlessly integrates into your LMS, whether it's Canvas, Moodle, Brightspace, or Blackboard, to create dynamic, interactive math assessments and activities. I'm going to quickly go over the agenda for this 30-minute session. We're going to start with a brief overview of Atomic Jolt and what we do to enhance teaching and learning in your LMS. We'll then do a live demo of Atomic Assessments. For this demo, we'll be doing it in Canvas, but please note that its functionality is the same whether it's in Moodle, Blackboard, or Brightspace. During the demo, please feel free to put all your questions into the chat or Q&A, and we'll be sure to answer them all. The session is being recorded, so I will follow up with everyone after to share the recording. If you'd like to set up a more personalized one-on-one demo of our tools, or if you'd like to evaluate it with a free trial, I'll include a link to my calendar in that email as well. But now I'll pass this off to Joel, who will get us started.
Great. Thank you for attending. Um, a little bit about Atomic Jolt. We work have worked in higher ed and K-12 and with ed tech companies for over a decade now. Recently celebrated our 10-year anniversary. You can see that we're partnered with these major LMS companies as well as other proctoring and accessibility companies. We also have customers in the US, in Australia, and Europe, around the world. And we have a number of products that we offer. The two most widely adopted are Atomic Search, which adds a search box to every page in your LMS and lets you do full text search of all your course content and saves you time. Atomic Assessments, which of course is the focus today, gives you sophisticated testing so that you can do more than what you can do with your LMS quiz tool. It integrates with proctoring, has all kinds of functionality, and the focus today is on its support for mathematics. And then we have other tools to support student engagement, polling, discussions, journals. All of these, including Atomic Assessments, can be inserted directly inside of your content. So in addition to having them, especially with assessments for testing, you can also create interactive curriculum content that engages the learner and asks them to participate. We also offer curriculum development services and also custom software development. We help ed tech companies integrate their platforms, also universities, when they need something customized about their LMS, we help them do that. So we'll go ahead and turn time over to Heidi about Atomic Assessments. As we've mentioned, it's sophisticated testing as well as interactive courseware. And people come to this typically when they're trying to push the boundaries of what their LMS quiz system can do for customized purposes, whether it's around high production quality business content, for exec ed type things, for nursing, where you're trying to prepare people for specific tests like the NCLEX, and then also with STEM, where you need this rich support for mathematics. And that's, again, where the focus will be today. So I'll turn time now to Heidi to show some examples of how we support math inside of Atomic Assessments.
Thanks, Joel. So like Joel said, our goal here is to show you how Atomic Assessments can really bridge the gaps between what LMSs typically offer in terms of what you can create for math content, and really, with a piece of paper, with a worksheet on a whiteboard, any type of math problem that you need to build. And obviously I'm maybe a little biased, but because I work for the company, but I really love atomic assessments. And as I've been building math assignments, I really haven't found a content area or a question type that I couldn't build in atomic assessments. So I'm going to show you a few question types to start with that really can be adapted for any type of math content. And then I'll show you some of our graphing question types. And then we'll go into some of the ways that the settings are and features are set up to make it as robust as possible to give your students a really engaging and authentic math learning experience. So this first question type that we're looking at is a just general math entry. This is just typing in an answer. This question type is really versatile. I can add images, I can add graphs, I can ask the students to provide an expression or a formula or a single number. And so it's just really versatile for whatever kind of problem we have. We have this keypad to help me put in some fractions, some integers, sorry, not integers, exponents, square roots, anything that the students might need to type in, I can set up in the keypad. And so they can have a real writing experience like they would write it on a piece of paper. This is the same question type, just showing that instead of having an expression here, we can have just a space for a single number. Again, we can have an image supporting the question. We can add a calculator so that, calculator accessibility and calculator type, students have different types of calculators. So neither of those are an issue. So everyone has access to a scientific calculator on the page. The next type of question that's really helpful is the label image question type. So we could use this with graphs, we can use this with shapes or physics diagrams where we want students to label, different vectors or different parts of the graph. And these have the same functionality as the previous math entry. You can, as you can see here, when I click in the text box, there's not a keypad that pops up for questions that don't need, anything other than their keyboard. You can turn that off so that it's more simple for the students to enter. We have a different calculator here, just showing that we have a scientific calculator option and a regular calculator option. And like I said, those two question types can be used with practically any type of content. And there's so many ways that you can set them up and use them and just have them be in a robust and authentic math experience for students. Next, I'm going to show you several of our different graphing options. These are very specific. If you need a histogram, you need a histogram, not a line graph. So we try to have several different types of graphs that you can build to fit exactly what your content needs. This is our just regular grid graph. You can do points, you can do lines on this. You can choose which tools students have available. So because I've asked them here to build a scatter plot, they don't need a line tool. So they only have a point option. So they can add points on the graph. And then really nice thing is that they can move it if they realize that they've put it in the wrong spot. So besides just being a graphing question, we can also make this a multi-part item and ask follow-up questions after or have questions before so that students are using multiple skills and thinking about the information that we're presenting them in multiple ways. We also have a number line graphing type, so you can do things like inequalities. And the nice thing about this one is you can have multiple sections on the graph when you're doing systems of inequalities, regular inequalities. We also have our line graph type, where students can drag the points to create their line graph. And like I mentioned earlier, you can add more parts to the question so that they can analyze the graph that they've built. We also have our histogram. So similar to the line graph, students can drag each section of the graph. And then here we also have our dot plot. So really, whatever type of graph you need, and we've tried to have an option that can work for the type of content or the type of data that you're working with. So the next, actually, I'm going to pause. If there are any questions about the question types that I've shown so far, I want to answer those before I go on to my next section.
Sorry, there are no questions right now. But if you
No
have
questions.
questions,
Awesome.
feel free to drop them into the chat.
Thanks, Lauren. So this next section I want to show is how atomic assessments makes it easy for both the, if it's the instructor or the curriculum developer, whoever's building the questions, and the student to really have a robust notation system where you can create anything on the screen that you would be able to write on the board or on a piece of paper. So here, matrices, things with really complex notation can easily become just unreadable if a system isn't designed to have them that way. I remember as a student having to type in exponents with the caret symbol and not having them actually show up as exponents. So then you have to worry about how the computer is reading them. So here our goal is that the notation is accurate and students have no difference between how they would write it on a piece of paper and how it would look when they enter their answers. So here we have some matrices. The nice thing that I really love about this is that I can give the students all the matrix tools that they need here to be able to type in their answer. This is not the correct answer, but they can, type in their answer and have it look the way that it should. And we have the matrix option here. And there's several other keyboards that are available, if you're doing trig or, sets, discrete math, things like that. We have several types of keyboards that you can use to give your students the exact symbols that they need. The next feature that I think is really helpful is that you can tell the system how to evaluate the correct answer. So I remember being a student in a math class the very first time that we had online math homework. And I remember having a problem where the correct answer was 3.5, and I typed it in as 7/2, which is numerically equivalent, but the question didn't tell me that it had to be written in a certain format. So it counted it as incorrect, even though it was the same number. I just formatted it differently. So, as a student, that's incredibly frustrating to not know that you have to write it in a certain format. So the validation settings here help us avoid that problem. Obviously, there are times when we want students to have a very specific format to what they're writing. I'm not saying that that's not important, but there are times when you're first learning a subject that it really doesn't matter as long as you get the number correct, and we can work on format later. So the three main settings here, there's a couple more, but these are the main ones that I use. You can set it to be literally equal to, symbolically equal to, and numerically equal to. So literally equal to would be when you need the format to be exact. You want students to enter in an answer exactly the way that you have set it up. Symbolically equal to is when you would say, okay, I don't care if it's 7/2 or 3.5. I don't care if it's x plus 2 or 2 plus x. As long as it's symbolically equivalent, it's fine. Numerically equal to is similar. It's mostly focused on numbers. That would be our fraction versus decimal setting that we would use for that. So I want to show you how that works. So here the correct answer is this expression up here, 3x squared plus 13x minus 30. I'm going to enter the same answer, but with two of the terms switched so that we can see how it evaluates the answer. Now, these are technically the same expression. Oh my goodness, just written in a different order. Now, if we check our answer, we can see that because it is not literally equal to the correct answer that I've set, this first one is counted as incorrect. But the other two recognize that they are symbolically or numerically equivalent. So it will accept that answer as well. Numerically equivalent I would not use for something like an expression like this. I would save it for strictly number answers, but it will work the same as symbolically equal to. So to show you another example of that, I have, let me check. Okay, we've got time. So this is another example. This is a polynomial or a question where I've asked them to write a polynomial and I haven't given them any instructions on formatting. I don't care if they simplify it or if they just keep it in parentheses form. So like before, if we type in the simplified answer, it should recognize that it is correct. Okay, so it recognizes that it's not literally equal to the parentheses answer, but it is symbolically equivalent. And like I said, I wouldn't use numerically equal to for questions that have anything other than straight numbers. But for this question, when we don't care about format, I would use this setting so that students can put it in as parentheses or as a simplified expression. Now, for a number example, if we want something to be numerically evaluated, the nice thing here is that we can also add a window of tolerance. So for some questions, maybe we're not focused too much on rounding, or I've seen questions where we're looking at a graph and estimating the line of best fit. Even if you do it perfectly correct, you know, two people might get slightly different answers. So it's really helpful to have that window of tolerance where you as the instructor don't have to say, okay, I'll accept 4.1, 4.15, 4.16, 4.17. That's really tedious. So having that window of tolerance is super helpful. And this one here will accept anything between 0.42 and 0.44. So I can see that it has accepted that because I've created a window of tolerance. So those are the validation settings. They're so helpful to make sure that the system is evaluating your answers the way that you want them to be evaluated. The last two things I want to show you are two really helpful question. One's a question type, one's a question feature for math. You know, as we're really in this age of AI and technology, right? There's so many ways for students to just get answers from each other, get answers from the internet. And it's also just really tedious to have to create multiple versions of questions, especially when you're authoring, you know, an entire exam. So these two features really help you create multiple versions of the same question easily. And that can help, you know, with cheating. It can help with practice assignments if you want students to be able to do a question multiple times and not have to write every single version of the question. These are super helpful. So this first one is a data table where you give the question a, you know, a CSV file and give it all the different options of values that you want it to take. Excuse me, sorry. I feel like I'm going to sneeze. If I do, I'll mute myself. So you give it a CSV file, you tell it these are all the options, and then you input the variables into your question. And every time that a student takes the assignment, they'll get a different option from your CSV file. The really awesome thing about this is that I can use those variables in a follow-up question. So whichever variables they're seeing here, I know that they're seeing the same ones here, and I don't have to worry about it giving them two different problems when I want them to continue working on a single matrix addition problem. The limitations of this is that you have to build all the options. So it does take a little bit of time to make all the rows in the CSV file, but you know, once it's done, you have, you know, you can have 20 different versions of the same problem. And you don't have to have more than one actual question. So that's really nice. The other type is our math generator. This is basically where you input parameters and then you tell the computer how to calculate the correct answer. And then it will generate up to 50 randomly generated values for those parameters. So the nice thing about this one is that you don't have to write all the options. You set the parameters, you tell it how to evaluate the correct answer, and it does the generation. The limitation here is that your correct answer has to be something calculable. So something like, an integral, I haven't figured out how to get, a giant integral to be calculable in the math generator. That's probably a little too complex. But, if you're doing the, quadratic formula or, something like this, like matrices, I can have the computer calculate this so it's able to generate a correct answer. So there's two different use cases, really, depending on what your question looks like and what kind of content you're working with. But this is so nice that I have up to 50 different versions of this question. And, I didn't have to do really that much work to get that many versions. So those are our features that I wanted to share with you. And then, when students submit their assignments or when as instructors look at it, obviously I wasn't focused on typing in the correct answers, but you can add in features like this that show students, these are your algebra questions and you didn't do so well on them. These are your finite math questions. And so you can set up levels of labels and tags like this when you're authoring questions to help both students and instructors have more categorized results. Okay, who are we turning it back to?
Let's pass this off to Joel.
All right, thanks, Heidi, for sharing those things. Here's and a little further details on those outcome reports. As an instructor, you've got a number of reports. One of them is outcomes, which helps you see again the breakdown of the subscores. She showed briefly something we call dynamic questions, which are those questions that you can generate with parameters. And so if you're authoring those, it kind of looks like this. So you can put those parameters in the question and then also in the answer. So when you're writing how to evaluate this is where you would choose that method, symbolic, literal, or numerical equality. And then you can use those parameters in the expression there. And so this is a question that asks, gives someone two sides of a right triangle and asks them to find the hypotenuse. And so, you could have, if you do this with parameters, you could write the answer in terms of those sides, again, using those parameters to evaluate it. And of course, I need to screw back here. So that's just a brief explanation of how you use how you do dynamic questions and the key part of it really is making parameters. And so the way you do the parameters is here, you can come up to data table, and then you can make a table of values. You can see here's 10 versions of this, and each of those has those values specified in the table. You can either manually edit those, or if you want to, you can write a script to do this. So the math generator does something roughly like this, but if you're a little more adventuresome, you can write some JavaScript and say, okay, I want these to be my parameters. I set my columns in my table, and then I'm going to do a loop through here. And then I'm going to add a row each time I go through the loop. And so if you run that, it generates you a new set of values. You can copy them into your table, and then let's see. And then you can apply them. And now you've got those values in there. So that's just one more way to generate values a little bit more flexible than that question generator to be able to use in a question. I'm just going to briefly show you a few other examples of things that are math related. One Sometimes you might want someone to be working through an extended problem. And so you can have, break that down into steps and have them work it out. You can even have an image that uh, has answer boxes on it, and they can be checking that and getting feedback along the way. One more example of this is kind of an interactive curriculum type of scenario. Oftentimes we think of this in terms of just question, question, question viewed one at a time. But here's an example of an entire page of content created in atomic assessment. So when you add questions to an assessment, you can say, I want all these displayed at once. And in this example, it's showing this is actually a Google Sheet embedded right here in the page. And so this is a kind of a custom integration, but it gives you some ideas of the flexibility. So I'm kind of showing two things here. One is this is interactive curriculum, and part of how that's accomplished, you can either insert these inside of existing LMS content, or you can make an entire module item be rendered by atomic assessments. Another kind of, well, I think I'm going to try and wrap up with one last thing. Uh, you probably know that Atomic Assessments is built on top of Learnosity. Learnosity continues to come out with new functionality, and so they have now released the ability to use AI to help you author questions, but they're also now leveraging AI, and this is not in our product right now, but will be by the end of the year, is this ability to have to actually be able to write uh, as shown here, math, either using your mouse and have it do hand writing recognition, or be able to upload a picture of something written on a page that again it could do handwriting recognition on. Then being able to also do feedback on multiple steps of math. So I'm putting the link into the chat right now where you can go look at this. There are some demo videos of these things of what's coming. You'll be able to see that. And then, as they make it available, then we turn around and make it available to our customers. So I'll stop there. We're at time. Thank you for attending. Lauren, if you want to wrap up, I'll turn it back to you.
Awesome. Thank you, Joel. Well, everybody, thank you for joining today. Be on the lookout for my follow-up email. I'll have a copy of the recording there. If you're interested in scheduling a more personalized one-on-one demo, I'll have a link to my calendar, or we can also discuss a free trial for you to assess our tool as well. Have a great rest of your day.